So in today topics are first point, equilibrium and types of equilibrium. That is the first topic. And the second topic what we'll discuss is the representation of all thermodynamic processes. Thermodynamic processes on PV diagram. Okay. And as well as the third topic, what are different types of thermodynamic processes? There are 5 to 6 thermodynamic processes. So all 3 to 5 to 6 thermodynamic process we will discuss with definitions and equations and all. And also we will draw on PV and TS diagram also. It is important point of for exam point of view. Okay. First is equilibrium. So what do you mean by equilibrium? Equilibrium. And we are discussing the equilibrium with respect to thermodynamics point of view. So whenever I use the word thermodynamics, first imagine there is a system. System, nothing but it is a device. Okay, it is a machine. So anything outside the machine, outside the device, we will call it as surrounding. So the layer, the partition which separate the system and surrounding is a boundary. So you need to remember these three terms. So whenever I discuss thermodynamics. So for now, I will not focus on boundary. I will be focusing on system and the surrounding. Let us assume that the pressure of the system is 2 bar. Surrounding temperature pressure is 1 bar. We can say that system and surroundings are not in equilibrium. Not in equilibrium because system pressure is 2 bar and as well as surrounding pressure is 1 bar. So both have values are not same. So when the values of pressure, temperature, volume, etc. are not same, you should use the word not in equilibrium. Okay, if system pressure is 2 bar and surrounding pressure is also 2 bar, then you can use the word both system and surrounding are in equilibrium with each other. Now the question, next topic, I will discuss the questions later. There are 3 types of equilibrium will come to the picture. First type is mechanical equilibrium. Mechanical equilibrium. And second point is thermal equilibrium. Third equilibrium is chemical equilibrium. Okay, it is one of the important questions they may ask you in the internal assessment and as well as semester exams. How the question will be asked? Define thermodynamic equilibrium or explain 3 types of equilibrium. Okay, first what we'll discuss is mechanical equilibrium. It looks like complicated, but it is not. So it is easy, you can understand easily. So mechanical equilibrium is nothing but, again, always you consider one system. So let me explain in the below space. Yeah, here. So mechanical equilibrium. So remember, mechanical, it is related to pressure. In this case, it is related to pressure. Thermal is related to temperature. Chemical is related to word reaction, chemical reaction, concentrations. Okay, so remember, mechanical is related to which property? It is pressure property. Thermal, T stands for, it is related to temperature property. And chemical, it is related to C. C stands for concentrations or some reaction. Okay, underline the word reaction in your mind. So mechanical equilibrium is what? The system temperature pressure is 1 bar and surrounding pressure is also 1 bar. Then you can use the word system and surrounding are in mechanical equilibrium with each other. Okay. Now, how to write in the definitions in standard way? So, mechanical equilibrium, it is a equilibrium in which the pressure of the system, or you can use pressure force, because pressure is equal to force by area. Some books they will also write pressure force. So, pressure of the system is equal to pressure of the surrounding. When if it is equal, then you can say mechanical equilibrium with each other. If the pressure of the system is 8 bar and surrounding pressure, that is atmospheric pressure, if it is 1 bar, we can use these system and surroundings are not in mechanical equilibrium, because I am focusing only on the pressure. These two may be thermal equilibrium because I don't know the temperature. So I am focusing only on the pressure. So pressure values are not same. So it is not mechanical equilibrium. If the pressure values are same, then you say it is mechanical equilibrium. For example, right? Pressure of system, if it is equal to pressure of the surrounding, then you can use the word system and surrounding both are in mechanical equilibrium with each other. System and surrounding. Understood? Any doubts here?
No, sir.
Okay. Now coming back to the second point, as you know, could you tell me what is thermal equilibrium now? Using the concept of mechanical equilibrium, could you tell me what is thermal equilibrium?
When the temperature is same in both system and the surrounding is called
Correct,
thermal
correct,
equation.
correct, correct. Very good. So when you should say the system or device is in thermal equilibrium means when the temperature of the system and temperature of the surrounding, if both system temperature, for example, let me take system temperature is 30 degrees Celsius and surrounding temperature is also 30 degrees Celsius. Okay, if the temperature of the system and temperature of the surrounding both are same, then you can use both system and surrounding are thermal equilibrium with each other. Understood? So when will it occurs? When this condition will be occurs, for example, let us consider your petrol engine, bike engine, petrol engine. So when you start the engine, the temperature of the engine cylinder approximately it goes to on 400 degree or 200 degrees Celsius. Let us assume. Okay, engine temperature is 200. Okay, and the surrounding temperature is 40 degrees Celsius. In this case, dear students, could you say these engine and the surrounding is it in thermal equilibrium with each other? Engine temperature is 200, atmosphere temperature is 40. Whether it is in thermal equilibrium with each other?
No, sir.
No. So in this case, this is not in thermal equilibrium. But when your bike, petrol engine, you park inside the parking area and you are not starting the engine for 4 hours of time. So after 4 hours, this 200 degrees Celsius engine will reject heat to the surrounding and both will come to an equilibrium temperature. Correct? That equilibrium temperature may be 50 degree. After 4 hours, after 5 hours, for example, today evening, 6 o'clock or 7 o'clock, you have stop riding. Your bike is in the parking area. So you are not starting engine throughout the night. Okay. At the early morning, if you measure the temperature of atmosphere and petrol engine, both will be same. So that is what the meaning of thermal equilibrium. So temperature of the system is equal to temperature of the surrounding, then we should say it is a thermal equilibrium. Now the going to third point, chemical equilibrium. So chemical equilibrium means there should not be any reaction. As the name indicates, it is chemical. Chemical equilibrium. So when you should say chemical equilibrium is, and there is no reaction between system and surrounding. So there is no concentrations, there is no high concentrations, low concentrations, or there is no transfer of concentrations. There is no chemical reaction is going on between system and surrounding. So in that case, we will call it as chemical equilibrium. Okay. So now the next point is the important thermodynamic equilibrium. They may ask you for 2 marks or 3 marks. The definition of thermodynamic, it is important. What is thermodynamic equilibrium is when the system and the surrounding is in chemical equilibrium, thermal equilibrium, and as well as mechanical equilibrium. You take any system and that system should be mechanical equilibrium with surrounding, that system should be thermal equilibrium with surrounding, that system should be chemical equilibrium with surrounding. If that all three conditions are satisfied, then you can say that both the system and surrounding are in thermodynamic equilibrium. So I will give an examples. You tell me whether it is thermodynamic equilibrium or not. Dear students, let me take the system. Okay, I will give examples. Okay, case 1. This is case 1. I will give some conditions. So you tell me whether it is thermal equilibrium or chemical equilibrium or mechanical equilibrium or it is a thermodynamic equilibrium. Okay, surrounding temperature, surrounding. Let me take the system pressure is 10 bar. Okay, and surrounding pressure is 10 bar. System temperature is 40 degrees Celsius. Here the temperature is 100 degrees Celsius. Dear students, now you tell me, in case number 1, it is related to which equilibrium and it is not related to which equilibrium?
Mechanical, it is related to mechanical, it is not related to thermal.
Yes, very good answer. So this system having pressure of 10 bar, surrounding temperature is also same. So it is mechanical equilibrium, ME. But when it comes to temperature property, both system temperature and surrounding temperature are not same. So it is not a thermal equilibrium. It is not a thermal equilibrium. Let me take the case number 2. Case number 2. Let us consider a glass of water. Okay. So a glass of water having a temperature of 50 degrees Celsius, having a pressure of 1 bar, and here on the surroundings the temperature is 50 degrees Celsius, the pressure is 1 bar, and in these conditions I am just inserting some oil. Oil is there on the surface of this oil liquid. There is some oil and there is no mixing of water and the oil. Okay, because of density difference, as you know. So it is not undergoing any chemical reaction. No chemical reaction is undergoing between the water and oil. So if any mixing of water and oil, you can say that there is a chemical reaction. Some mixing process is there. So it is undergoing a chemical. But here I am using the word there is no chemical reaction. So in this case, so it is what you call, what type of equilibrium will you call?
Thermodynamic.
Thermodynamic equilibrium, because as I said, temperature is also same, pressure is also same, and I use the word there is no chemical,
and there is no chemical reaction.
Correct. It is a thermodynamic equilibrium. Have understood? Equilibrium, chemical equilibrium, thermal equilibrium, and thermal.
Yes.
Okay.
Yes.
So next process is, so all these processes are important, my dear students. These processes will be used throughout thermodynamics, not only here. So thermodynamic processes are very important. So based on these thermodynamic process only, we will solve numericals on of chapter 1, chapter 2, and as well as 3, 4, 5. Okay, this is a basic knowledge you require. Thermodynamic systems, thermodynamic processes we will call. Okay, we'll call it as processes. These are also called as displacement processes. Displacement processes. Okay, remember the first point, thermodynamic processes are isobaric process. Okay, later I will discuss the definitions and I will give a hint how to remember all these thermodynamic processes. Isobaric process. Second one is isochoric process. The third one is isothermal process. Fourth one is adiabatic process. Fifth one is polytropic process. Okay, these are the names of the process. Okay, some books they may use the word isobaric displacement process, isochoric displacement process, isothermal, adiabatic, polytropic displacement process. Okay, that is first point. The second point what we need to remember here is this isobaric may be expansion, may be compression. For example, if I say the volume of the system is increasing, for example, initial volume of the system is 1 meter cube. Let us assume that the system is a balloon. Okay, when the size of the balloon increases, okay, you should say it is expansion process. When the size of the balloon decreases, you should say it is a compression. So size of the balloon I am using, but inside the balloon it is air as a working fluid. You should change the word, the volume of air, instead of using the balloon. Balloon is a device, understood? So where the air is encountered. So you should say the volume of the air decreases, then you should say the air is undergoing compression. If the volume of the air increases, okay, then you should say it is a expansion process. The air is undergoing expansion process. The air is undergoing compression process. Keep in mind, because in some of the engineering applications, the volume of the device will be constant. There is no change in the volume, but the inside working fluid volume changes. Okay, for example, I will give one piston cylinder arrangement. Assume it is a bike engine. So when the petrol enters inside the cylinder, the volume of the cylinder will not change, because assume that you are coming from your home to college. Whether the volume of the cylinder, bike cylinder is changing? No, the volume of the cylinder is same. 150cc bike, so Pulsar 150cc bike, the volume of the cylinder will not change, but the quantity of petrol which enters inside the cylinder will change with respect to some time. In sometimes, due to if you are giving most accelerator, the volume of petrol going inside the cylinder increases. Understood? The quantity of water, you can say the volume or quantity of water, quantity of air, quantity of petrol, diesel. Just an example I am telling you. But depends upon the conditions, the quantity volume will changes. So if the volume increases, keep in mind, if the volume increases, you should say expansion. So in that case, I use the word isobaric expansion. If the volume decreases, you should say isobaric compression. That is a simple word. Third point, what you need to remember here is definitions. Okay, so now look at the board. Important. Isobaric process, it is a process, or it is a thermodynamic process. It is displacement process in which the pressure during the process is constant. Pressure during the process is constant. Okay, how to define the definition of isobaric process? Isobaric process is a process. It is a thermodynamic process in which the pressure throughout the process or during the process is constant. So any process where the pressure during the process is constant or the pressure is not changing, pressure value is same, so you can call it as isobaric process. And dear students, what is the hint how to remember isobaric is related to pressure? So here bar, in the previous class you might have used the word bar. So bar is a unit of pressure. So isobaric is related to pressure. Just how you remember. Okay, in the isobaric process, pressure remains constant. Similarly, the second point, isochoric. Choric is nothing but it is a Greek word. It is related to volume. Volume. Now, how will you define the second process? A isochoric process, a process in which the volume during the process is constant. It will not change. You can write in different way, my dear students. It is not perfect always. There is no rule that you have to write same words. You can change the words, but concept should be same. Isobaric process is a process in which the change in volume is zero. Understood? That is how you can also change in volume is zero, or there is no change in the volume of the process. Okay. I will give an example also. Do not worry. I will give the examples. Isothermal. Is anybody, my dear students, could you tell me what is isothermal or what is the definition of isothermal?
It's about temperature, sir.
It is related to temperature because thermal is related to temperature. So a process in which the temperature is constant throughout the process is called as isothermal. I will write no change in temperature during the process. Okay, no change in temperature during the process, or you can say temperature during the process is constant, or you can write three definitions, my dear friends. All three will give the same meaning. Okay, let me tell me in detail. First point, no change in temperature during the process. Second point, same word, same definition. I will change the words. Instead of writing no change, I will write change in temperature during the process is zero. For example, initial temperature is 30 degrees Celsius. Final temperature is also 30 degrees Celsius. So 30 minus 30, change in temperature means final temperature minus initial temperature is zero. That is also correct. Correct. Isothermal process. No change in temperature is also correct. Or temperature during the process is constant. Constant temperature. That is also correct. Okay. Next, adiabatic process. This is a little bit tricky. So try to remember. Okay, it is important. Industry, they use adiabatic processes in many cases. Okay. Adiabatic process is nothing but there is no exchange of heat, underline the word heat, between system and surrounding. What is adiabatic process? A process in which there is no exchange or no transfer of heat from system to the surrounding or from surrounding to the system. Okay, let me give an example. Okay, you tell me whether the heat is same or not. Here again it is system. This system has a temperature or has a heat of 100 joule. 100 joule. Assume this is your body temperature. Body temperature in the rainy season or maybe winter season. In the winter, your body temperature will be more than the surrounding. Surrounding means always cold in the winter season. Your body has a heat of 100 joule and surrounding the atmosphere has a heat of 50 joule. Let's assume your body will be rejecting heat to the surrounding. Okay, your body is continuously rejecting heat to the surrounding. So once your body rejects heat to the surrounding, you will sense cold. So what you'll do, you'll wear a sweater. Understood? So that sweater, for example, if you wear a sweater, assume that this is a sweater on your body. Assume that you are wearing a sweater. So you are a body, system is your body, correct? Okay. So that sweater, what it will do, it will resist, it will stop the exchange of heat from your body to the surrounding. So this cloth, that is sweater, acts as a adiabatic process. I hope you understand. Okay. Adiabatic process is nothing but any process, any layer, okay, it resists or there is no exchange of heat between system and surrounding. Any doubts in adiabatic process?
What, sir?
Any doubts? Any doubts you have in adiabatic process?
No, sir. No.
Okay. I will give an industry example. Okay. So this is a general example. Steam turbine. Let us consider one steam turbine. I'm using the word steam turbine. It is thermal power plant. Okay. In the thermal power plant, they are using steam turbine to generate mechanical energy. So this mechanical energy they will supply to generator. Finally, they will generate electrical energy, that is power, current. Okay. So this turbine will be used in thermal power plant. Thermal power plant is nothing but they are generating electrical energy. Maybe in Raichur it is there, in Karnataka, and in Tamil Nadu it is there. Okay, many places in Karnataka and or India. Steam turbine, the temperature of the steam which enters inside the turbine has 1000 degree Celsius. Okay. And dear students, what will be the temperature of the surrounding in particular area where the thermal power plant is located? Whether the temperature of the surrounding in the Ballari, whether 1000 degrees Celsius will be there? Atmosphere temperature will be how much in Ballari side?
Oh, sir.
On an average,
Minimum
how much?
40, sir.
40 degrees Celsius.
40 or
Minimum
36.
40, 36, very good. So there is a difference in temperature. Here the temperature of the steam is 1000. Temperature of the surrounding air is 40 degrees Celsius. So there is a large gap in temperature. Difference in temperature is more, 1000 to 40. When there is a difference in temperature, there is an exchange of heat. This is a basic phenomena, correct or not? When there is a difference in temperature is there, there will be exchange of heat. Then in this case, the system that is called as steam, the steam starts rejecting heat to the surrounding. When the system, that is the steam, working fluid steam, starts rejecting heat to the surrounding, will not get high efficiency. Efficiency of the turbine decreases. Efficiency of the turbine decreases. It should not happen. So what we need to do as an engineer, we should restrict the energy, the heat which transfer from the turbine to the surrounding. What will do? They will insulate the turbine. What they do? They will insulate the entire turbine with the help of some cotton wool, some insulated glass wool, whatever may be. Okay, glass wool they will do in industry. Okay, so this glass wool restrict the transfer of heat from the system, that is turbine, from the steam to the surrounding air. So that process is called as adiabatic process. We can use the word insulation. It is the best word, insulation. So what is adiabatic process? A process in which it is no exchange of heat between the system and the surrounding, that is called as adiabatic process. And polytropic process is also same as adiabatic process. When we are deriving some equations, we'll discuss polytropic. What is the difference between adiabatic and polytropic? Almost both are same. There is a slight one point is difference. Any doubts in these classes? in these classes and in today class also?
No, sir.
Okay,
Sir,
so
but what is
whatever
the polytropic
I will
process? I didn't
I will
understand.
discuss in the next topic, because if I told here you will not understand. So almost polytropic and
Okay.
adiabatic are same. Polytropic and adiabatics are almost same, only there is some little different. Let me tell you what is the difference here. In the adiabatic process, in solving numericals or some simplifying the numericals, I will be using gamma. I will be using a symbol gamma. But in polytropic process, I will be using one alphabetic letter, that is n. That is one. Gamma value is 1.4, it is standard, and here n may be any value. It is more than 1.4. There is a difference. I will tell you in the next topic. I will tell you all the details. What is n, what is gamma, etc. And how, what is the value of n for isobaric process, what is the value of n for isoquary. That is also very important, because in solving the numericals we need to remember n value. N is called as adiabatic index. Okay, here gamma I am using, I will call gamma as a adiabatic index. If I use n I am using for polytropic, so it is called polytropic index. Polytropic index. What is gamma? Gamma is related to adiabatic, so it is adiabatic index. In the next topic I will tell you all these. Okay, any doubts in today class?
No, sir.
Okay,
No.
so what we have done, first equilibrium, we have discussed the equilibrium point. What is equilibrium? Types of equilibrium also. Thermodynamic processes we have discussed. Okay, and thermodynamics representation in PV and TS diagram we will discuss in next topic, and as well as the value of n, gamma, etc.